data-oriented backups and imports using one of Kasten's tools, Kanister. My name is Aaron Alpar. I'm a member of technical staff of Kasten by Veeam. My background is in domain-specific database implementations for high-performance databases. Today I'm going to talk about who Kasten is. I'm going to talk a little bit about our products. I'm going to talk about specifically about Kanister, and of course, how to backup and import using Kanister. The presentation is going to be given basically as a series of demonstrations, and I'll be outlining the components of Kanister as I go along. The hope is that it'll give you an understanding of not only how Kanister is composed and its constituent components, but how to operate Kanister at the same time. There's plenty of, this is an open source project, so there's plenty of information available on our websites as well. So first off, a little bit about us. Kasten is a company that releases data management products, our flagship product being K10. We're basically Kubernetes data management, backup, restore, disaster recovery, and application mobility. Along with our commercial product, we have several open source products, Kubester and Kanister. Kubester is a volume characterization for Kubernetes. It's an excellent tool for allowing you to understand the performance characteristics of the volumes and volume classes that are supplied by your Kubernetes installation. Kanister is a data-oriented backup tool that also integrates with K10, but can be used independently. It is the subject, of course, of the presentation today. So what you'll need for this presentation is a Kubernetes cluster. I'm going to be using a DigitalOcean Kubernetes cluster remotely for the demos that I'm going to be giving here. Some very basic kubectl experience creating and retrieving resources with kubectl, nothing special. And you'll need a Kanister operator installed in your cluster. You don't necessarily need it, of course, for the demos that I'm going to be giving today, but if you intend to use Kanister in the future, you'll need the Kanister operator installed, and below is how to actually install it. So, a little bit about Kanister. Kanister is made of 4 components: the Kanister operator, blueprints, profiles, and action sets. Kanister operator is basically responsible for all of state management within Kanister system. It's responsible for state management of blueprints, profiles, and action set. It's what makes everything run. Blueprints describe how to back up a particular application in the system. Profiles describe where to back up that application to or restore that application from. Action sets describe states of individual backup actions or restore actions. It's basically a job to back up an application using a particular blueprint and particular profile. I'm going to be showing you a simple application. I will not discuss profiles until the next example. A simple application will simply use a log. This simple application is what we call a time log application. All it does is output date timestamps out to a file. The command that does that is here. It's very simple. This file will be the subject of our backup and restore operations. We're going to create a blueprint to back up this application. Again, the blueprint tells Kanister how to back up the application. It does this through actions, phases, and commands. Here's a simple blueprint. This is the spec file for the blueprint along with the command to create it. Blueprints are made up of actions. In this type, this is a backup action. You can have backup actions or restore actions. This type of backup action is to back up a deployment. Under the action, I have phases. Phases describes the steps to go through to actually back up the application. In this case, I only have one step in my phase, and that is to back up a deployment in the file that we output the date timestamps to, var log time.log. There are different functions that you can specify for phases. You can take a look at the project website, project website for Kanister on github.com to see details about this. We also allow templating within our blueprints. These allow you to pick up various variables from the system. Again, more documentation is on our GitHub website. Now, putting this all together, the action set tells the Kanister operator what application to back up with what blueprint. Optionally, I could associate a profile with this to specify a specific backup destination. Here's a simple example of an action set. Here, I'm creating an action set through a spec file. Here's the command we created along with the spec for it. Every action set has an action, in this case, backup. This is the same action that's specified in the blueprint. So this action set runs the backup action in the blueprint time log BP, and it specifies the object to backup, in this case, the time logger application. So here, the time logger blueprint, specifically designed to back up the time logger application, is being used to back up the time logger app. Here's an example of getting the state of an action set from the command line. I'll be showing you this in an example in the next section. So here, I'll show you the example application and the action. So how I'll be doing this is I'll be running a series of scripts from the command line that'll tie together the blueprint with the application and an action set all together to show you how a Kanister is actually used to back up applications. I'm going to be starting, of course, with our application, our simple time logger application, which is a type of deployment. All this application does, as we saw before, is output the timestamp out to a file. We'll be backing up the file as our target. Next thing we'll want is a blueprint. The blueprint, as we saw in our application, is going to have an action of type backup for deployment, which is the resource type of our application. It will have one phase, which is to run a script using the kubeexec function. All this script does, in this case, is cats the log out to the log. Basically, this outputs the time log out to standard out, so we can see it in the log. Later on, we'll actually be backing this up properly, but for now, I just want to demonstrate it. So now I'll go ahead and create an action set that backs up this application using this blueprint. Here, I've created the action set. I've pulled it to back up the deployment time logger using our blueprint. You can see the results of this by actually looking at our action set. So previously I created it. Now I'm actually looking at the results of the action set. As we can see, our phase is complete and our action set is complete, which means that it's finished running. We can then see that the output of that file has been printed out to the log. In this case, I parsed the log for the Kanister operator so we can see the actual output. In a moment, I'll show you what backing this up to an actual destination looks like. For now, it's just a log. Next, I'm going to talk to you about Kanister tools, Kanister profiles, and Kanister command line tools. Kanister profiles, as I mentioned before, represent external destinations for which data is backed up to or restored from. So profiles allow you to manage separately the where data goes or comes from, separately from how to back up that data. How to back up the data is represented by blueprints. Where to back up data to or restore it from is represented by profiles. There's some command line tools to help you with Kanister process. One is cancuddle, the other is can-do. Cancuddle, like kubectl, is designed to be used from the command line. It basically simplifies the process of creating action sets and profiles. Can-do is used from within containers to use profiles to export data or import data. It basically eases the process of using profiles from within containers to get your data out of a container or into a container. This is an example of creating an action set with kubectl. Uh, it's a verbose process. We've seen this before. There's a shorter way to do it, which is to use CanCuttle. CanCuttle shortens the process down by breaking it down into the required parameters, and it'll fill in the rest of the spec for the resource for you. In this example, we're running a backup action. Uh, we're running a backup action for our time log S3 blueprint. We'll see this in a minute. Uh, here's using a profile using CanCuttle. So profiles can also be managed by CanCuttle. This is an example of creating an S3 compliant profile using CanCuttle. I'll show you an example of this as well from the command line in a minute. Can do is used from within an application. In this case, this is using can do from within our time logger deployment that we had before. So everything that's not in bold is as we had it before in the previous deployment, the previous example. What is bolded is the modifications I made to utilize can do to export that data through a profile. We can imagine that this profile might point to S3, for example, which is actually what's going to happen in our next example. This is the previous example from our blueprint. So you can see here where the differences are from our previous application and those using can do. Next, I'll show you these tools in action from the command line. I'll be creating a profile using can control, creating an action set in can control, and also showing you the use of can do from a blueprint used to back up our time logger application. As before, I'm going to be using scripts to help me out. First, we're going to create our time log profile. Before, we were backing up our time log application without the use of a profile. In fact, we were just exporting the output to the log. In this case, we're going to create a profile so we can export that file to an external location. In this case, S3. To do that, I've created an S3 compliant profile. And I'm also using can control to go ahead and do that. So here, the profile is created along with a secret. So I get two objects when using can control, the profile itself and then the secrets to give you access to the external data source. So this is helpful because it separates the secret from the actual profile and can be managed separately. This command actually creates a spec, what's called a profile spec within Kubernetes. Here's the spec object for that profile. So this can be created using YAML, but it's easier from the command line. So here I'll go ahead and create a blueprint. I'm creating a separate blueprint because this blueprint uses can do to export the data to S3. It's very much like my old blueprint in that I have a single action to back up a deployment, a single phase to run a script in a container, and a shell command. That script is a shell command to export the time log file, var log time log, to an external location. In this case, I'm using can do. I could optionally not use can do and use the AWS S3 commands, for instance, directly, but can do has some other benefits, so I'll show you later on. At any rate, my new blueprint's been created, and now I can actually back up the time log application to an external source. Here, I'm going to go ahead and create the action set to perform the backup. Here, once again, I'm using can control to create my action set this time. Previously, I created a spec resource. I used YAML file to create a spec, a resource within Kubernetes. In this case, I'm creating the action set using can control. Is less verbose this way and debatably easier to do. In this case, I tell it which action to execute, in this case, backup. In this case, I'm going to perform a backup on the deployment, the namespace, the blueprint, and the profile to use. Talked about before, using profiles allows you to separate the how to back something up, as mentioned in the blueprint, from where to back it up to, as indicated in the profile. Here's the action set for that backup. And as before, we can see that the action set is complete. The phase is complete, and the entire action set is complete. Now I can take a look at that file that got backed up on AWS. Here, AWS S3 LS. LS is that file on the external S3 in the external X3 bucket. And I can see here the time logger file, and it's the backup date is basically now. The contents of that file are very similar to they were before, basically a series of timestamps. So this shows you how to use a profile as a backup destination for a Kanister blueprint. So we can back up, we can use a blueprint to back up data from an application to an external source. Next, I'm going to be talking about using Kanister to back up Postgres database to an external source. Kasten supplies many blueprints already for backing up and restoring normal databases. So actually one of our goals is to provide these blueprints so that you don't need to develop them yourselves. I find that it's helpful to understand how a blueprint works. So what I'm going to be doing is taking you through a tour through a blueprint and showing you how a more complex and production-oriented blueprint works. I'll also demonstrate this blueprint in action, backing up a Postgres database. You can modify these blueprints to perform more complex actions such as filtering data, sanitizing data, and so on and so forth. So thus, it's useful to be able to modify these. This is the Postgres blueprint. This is available on our website under standard blueprints. I'll provide a link to it at the end of the presentation. There's a lot to it. So what I'm going to do is break it down and simplify it. So what I've done is taken the blueprint and removed a lot of the redundant portions. We're looking at the backup phase right now. The restore phase looks much the same. So I've removed that. I've also removed a lot of the supporting elements that are used for the Kubernetes resource object. So the meat of the blueprint is in bold right now. So we have, as we discussed earlier, we have backup, we have phases, and we have args. Args are where the commands are executed. And if you're familiar with Postgres, this should be a familiar command. This is the meat of the backup. It's pg dump all there's a pg dump all, which pipes it to gzip. Of course, there's a lot more going on here, and I'll cover some of that. As we've seen before, we can take our output and we can pipe it to can do. And can do will push it out to a profile specified on our action set. So these are specified in these variables here. pg dump, of course, needs to know what host to use and what credentials to use in order to perform the backup. Those are these variables here. If you work with Postgres, you should see these before. You should be familiar with these. These values actually mostly come from parameters within the system. For example, the PG host, the host to actually run PG dump all comes from a pod of a stateful set that's running within the system. These, these template parameters, as I discussed before, are standard Go template parameters. They're expanded to produce the name and namespace of the pod that we'll need to access. Uh, there's more documentation on how these templates are expanded within the Kanister documentation. So again, I'm just giving you an overview here. PG user is Postgres, of course, and our PG password also comes from secrets, since we don't want to embed secrets inside of our blueprint. You'll notice that here, this is an index to an element which is actually contained within this blueprint. Phases, PG dump, and then PG secrets, as we can see here. There are phases, our PG dump, and our PG secrets. And then it contains the name and namespace of our secrets object. So again, it's helpful to be able to reference these parameters so we can use objects from within the systems and not have to embed everything within the script. Our backup location environment variable is being set here so that we can use it later on in can do. This, or previously you've seen can do as a way of using a profile to export to an external data source. Here, we're using can do to also output a backup location. So the backup location will be set within the environment variable, and then we can use that within can do to output it here. This allows Kanister to track our output artifacts so we can do restores later on. We don't have to actually go out to S3 ourselves, define those artifacts, and import them. Here's another variable reference for our backup location, and it's being used in the output artifacts once the backup is done. Again, there's more data on this on the website for Kanister. Next, I'm going to show you this blueprint in action by backing up and restoring a Postgres database. We provide a number of blueprints for backing up and restoring a standard set of databases. You're welcome to use these and then modify them for your specific purposes. So I just happen to have Postgres running locally. So first thing I need to do is load it up with data. Here I'm inserting 3 rows into it. And I can go ahead and select those rows to see that they indeed have actually been inserted. So I am then need to create a blueprint for this. This is the blueprint I mentioned, I showed you earlier in the slides. So it's the same blueprint. It is also the same one that's contained on the website. So here the blueprint has been created. And now all I need to do is create an action set. And again, in order to create an action set, I'll need a profile and I'll need a blueprint. Here we can see that we have our blueprint. And here we can see that I have a profile. So we can go ahead and create our action set. Here I'm creating an action set with can control. I'm creating an action set to back up my installation of Postgres that I have in my cluster. Here I set my profile name in an environment variable that's being used, but it's the profile that's being specified for the action set. I can check on that action set. It exists, and I can check on the status of that by getting the YAML for it. As we can see, the state is complete. The backup is complete. And in addition, the way that the blueprint works, it has a backup location. This is especially helpful. So we know what location the backup file is within the destination specified by our profile. We can then use this for restoration later on. I'll show you that. So we have our action set. Our action set's complete. Hopefully, We have our backup file in the backup. We have our backup data in the location that we expect. Sure enough, we have when I ls s3, we see that we have the directory that we expect here that's specified here. So all is well. Now that I have my data backed up, I can go ahead and delete my rows. So I'm preparing to restore this, and I'm deleting the rows to show that this restore actually works. So let's go ahead and select. And as you can see, when I select the data from Postgres, no rows show up. So the data is actually gone. Now I'm going to create another action set to perform the restoration action. I'll need the name of the action set that I created earlier on the backup. So I'll show you the command for this and show you what happens. So here again, I'm using cancuddle to create an action set. This is a restore action. I can specify a from action set name. Here, the action set name was specified on the command line, and I've set it through an environment variable. So this will restore from the backup to action that was created in this action set. Very helpful. Tell it where to restore to, and tell it what profile to use. So this presumably has restored the data from my backup action set into my Postgres database. So we can check on this. First, let's check on the restore action. It indeed exists. Check on the status of it. It is complete. And we can select rows from Postgres to see if it's actually worked. And sure enough, it has. So here you see an actual blueprint in action and backing up and restoring a Postgres database. So this presentation, you've seen how to use Kanister to back up and restore Postgres and other applications. Here are a few references that were mentioned during the presentation. Most of these are for Kanister. Remember, Kubernetes volume characterization is also available as open source project. I encourage you to take a look at the Kanister.io GitHub projects, specifically the example that we use for Postgres. Here are the blueprints for the blueprint example for backing up a Postgres database is the one that we use in the presentation. There's a number of other databases. I encourage you to take a look at it and play around with them to get used to using Kanister. Anyhow, thank you very much. If you have questions, please reach me via email, aaronalpar@veeam.com.